I work in a few different areas, but generally about the interaction between society and climate and the climate system in various dimensions. And lately that has meant a focus on climate change impacts, or what might the consequences of climate change be for society. And so what I want to talk about today is something in the impacts area, but it's partly about the science of impacts and what do we know about those consequences, and at least equal parts on communication, just communicating what we know at the moment about climate impacts. And that communication, I'm going to talk about a particular communication approach called the reasons for concern, which is in the title of the talk here. It's an approach to communicating impacts that was developed as part of the reports of the Intergovernmental Panel on Climate Change, which I'm sure many of you have heard about by now, right? This is an international group of scientists that get together every 5, 6, 7 years, a few hundred scientists to write fairly large reports on what do we know about the climate change issue, and these are updated periodically. And around the year 2000, in that version of the report, they came up with this approach to trying to communicate climate impacts called the reasons for concern. It's been updated a few times since then. So why would you need to do that? You know, I mean, why don't you just tell people here's what the impacts are? The problem is that they are many and they're highly varied as well. Is that climate impacts can affect many different sectors of the economy, many different geographic regions. They can happen soon. They can be already happening now. They can be long-term. Some of them might have very large consequences. Some of them might not be so large. Or they may seem large to me, but you may not care at all about the stuff that I care about. And in that situation, when you're thinking about, okay, so to be more concrete, this could be impacts on agricultural production for certain crops in certain regions, effects on the agricultural economy and the prices people have to pay for food, or risks to hunger, or they could be impacts on coastal areas from coastal storms that may be changing in frequency and intensity, or sea level rise that's making the flooding worse, or climate change health impacts and mortality from heat waves, and so on. So there's a very long list. And as you might be getting the sense of right now, when you try to communicate something by making a big long list, people's eyes glaze over. So if you sense your eyes glazing over from that list, this is like a common reaction. It's tough to really grasp, okay, so, but all right, you just mentioned 20 things, so what's important and what do we have to worry about first, and is it a big deal or not? It's very hard to get a sense of that. So the IPCC, it's the acronym for this, you know, the panel on climate change, faced the same issue. They had a massive report full of impacts and wanted to try to boil it down and say, well, what do we think matters and how big of a deal is it or not? And that's important, as you can imagine, because understanding what the risks of climate change are and how important it might be to avoid certain impacts and how much worse they may get as we get more and more climate change, all of those things are really critical to having an informed response to the climate issue. Like, what should we do about it? And so it's an important scientific topic, important communication topic, because ultimately it's an important topic for informing our own opinions, but also our policies at the local and national and international level for dealing with the issue. Okay, so today what I want to talk about is basically three things. First, what are the reasons for concern? What are we actually talking about? And what was a bit more into the motivation for developing and kind of the conceptual framework behind the particular approach to communicating these risks that are taken. Second is how they've changed, how the just big picture impression of what we understand about how serious or not climate risks are has changed since the reasons for concern were introduced around the year 2000. It's been 15 and going on 20 years since then, so some things have changed. And finally, a little bit of a look behind the scenes about how are the risk judgments made within this framework to say, yes, this is a high risk, this is a low risk at 2 degrees or at 3 degrees. Ultimately, judgments are being made about this based on the science, and it can get a little intransparent as to how do you go from scientific studies to some kind of risk judgment. And so we want to look at those partly to understand better this particular framework, but partly to also understand its limitations. There's a lot that we don't know, and there are many ways in which even this attempt to clarify the communication can actually sometimes lead to misinterpretation of what the science actually says about climate impacts. And why am I talking about this? Well, I was, in the last IPCC assessment report, was in charge of the part of the chapter that did the latest update of these reasons for concern. And a whole bunch of other people participated in that as well, and that's all the other names on this slide here, all contributed. So I'm going to be talking about, this topic area of work that lots of people have contributed to. I also will be one of the co-leaders of the chapter of the IPCC report in the next update, which is going to start in about a year. And we'll be taking this topic on again. And so the reason that's important is if anybody has a good suggestion for how to do this better, we can immediately take it on board in the next assessment report and implement it as an improvement. So keep that in mind and think about your suggestions. Okay, so what are the reasons for concern? Well, in visual terms, they look like this. And don't worry too much about being able to read the print. We'll get to what everything that's on there eventually. Maybe a little difficult to see. This is the visual, the figure version of the reasons for concern. The figure version is often called the burning embers diagram. Hopefully for obvious reasons that it looks like maybe there's 5 things that are smoldering on here. And each of these 5 colored bars represents one reason for concern. And what those reasons are they're kind of categories of impacts. They're not individual impacts, but they're categories of them, which are meant to try to add up or average over lots of individual impacts that might be happening to individual sectors or regions or so on, and make some broad overall judgment about that category of impacts. And the bar, sort of the vertical dimension here, the y-axis, is global average temperature change. There's 2 different scales, but the one on the right is the global warming relative to pre-industrial, so back in 1850 or so, we call that 0. And then the numbers up the right-hand side are degrees C of global average warming since pre-industrial. And then the colors are the risk level. And they range from white, which is undetectable, we don't detect any impact yet, to moderate, to high, which is red, to very high, which is purple. And so in general, the way that this figure summarizes an underlying expert opinion-based evaluation of risks is to assign these colors to these different categories at different levels of global average warming. So for example, this second blue line that's labeled recent, I don't know if you can see it, but this one is about current climate. And at that level, a few of these reasons for concern are yellow, which means moderate risk. A few of them are white, which means we haven't detected any impacts in this category yet. At the high end, you can see 4 or 5 degrees, right? All of them are red or purple. So by the time we get up there to that level of warming, we've got high risks across all categories. And in between, different categories become riskier with different levels of climate change. So that's in broad terms the kind of result that this figure is aiming to communicate based on a lot of, probably hundreds of underlying individual studies. And the kinds of risks, and we will talk about this in more detail, the categories, you probably can't see them. The first one is risks to unique and threatened systems, and this is primarily a lot of biodiversity systems, coral reefs, Arctic areas. The second one is risks associated with extreme events, heat waves, heavy precipitation, et cetera. The third and fourth are sort of a pair. The fourth one is globally aggregated risk. So if you add up impacts globally, and it is a big number, that's a high global risk. Some risks may be important even if they don't add up to a large number globally, but are maybe very big in a particular reason, maybe a big impact for the US. And so even if it doesn't add up globally, then in the third ember there, which is risks associated with distribution of impacts, that's another category. And finally, the fifth one is called risks associated with large-scale singular events. And that was the terminology worked out to be things like big changes to the climate system, like ice sheet disintegration that leads to substantial sea level rise, major reorganizations of ocean circulation, relatively fast, say, collapse of ecosystems, so maybe a fast collapse of coral reefs, or the Amazon not being able to function as the Amazon forest anymore and transitioning into a totally different type of ecosystem, and that is the fifth category. Okay, so that's sort of the general idea of the reasons for concern. So basically, for the rest of the time, we're going to kind of unpack this and like, okay, what are these categories? How are they defined? How do you make judgments? And look at some examples of how was it that we went about and decided, well, in the unique and threatened systems ember, it should be yellow today, and it should turn red, with around 1 or 1.5 degrees of warming, and so on. Okay, so as I said, this is just sort of some insider IPCC work. The IPCC is divided into 3 big working groups that tackle different topics. One's climate science, one's impacts, one's emissions and emissions reduction. And so this is within a particular chapter in the impacts working group. And the name of our chapter is called Emergent Risks and Key Vulnerabilities. And that's a bit of an awkward title. The reason I'm showing is to sort of introduce the idea of key something. Like, so we're focusing on key risks, key vulnerabilities, and we want to see what that means. And the idea of this chapter, which is the one that the one that gave birth originally to the reasons for concern, was that this is a synthesis chapter. The Working Group 2 is full of chapters on what are the impacts on health, one chapter. What are the impacts on agriculture and food? What are the impacts on energy systems? And then a whole bunch on different regions. This one was to pull it all together and say, what should we really worry about? And by worry about, what that meant was what's important in the context of the UN Framework Convention on Climate Change and its main objective. And the UN Framework Convention on Climate Change was the original agreement. In the early 90s, countries get together and say, yes, we should do something about climate change. What should we do? And I think many of you have seen this before, is that, well, according to the Framework Convention, we should prevent dangerous anthropogenic interference with the climate system. And we should do it in a way that doesn't produce undue risks for ecosystems or food, things like that. And so dangerous interference with the climate system is not a strictly scientific topic. That's not something that you can write a report on and say, we nailed it. It's a value judgment on what you consider dangerous, I consider dangerous, other countries do. But it can be and should be informed by what we know about the science of climate change impacts. So the idea of this chapter and of the reasons for concern and this intermediate conception that we defined of key risks. Key risks are those that somebody somewhere might consider relevant to making their own decision on what dangerous climate interference could be. And so that was the aim of this chapter. Pull together all of these from the whole rest of the report and from our own assessment of the literature. What is the list of things that might be relevant to interpreting what it is we're actually trying to avoid in dealing with the climate issue, and then trying to communicate it. That's where the reasons for concern come in. Okay, and this is taking place in a risk framework. So we need to take a second and say, well, okay, but what is risk, right? We're going to collect key risks. We're going to categorize them into 5 reasons for concern. We're going to communicate them. What is risk? And risk, the important thing there's many different ways to define it or think about it. The important element here is that it is a product both of changes in the climate system and climate events, but also of societal conditions, right? Ultimately, what we're interested in the climate issue is reducing or avoiding impacts on people or on ecosystems that people care about directly or indirectly. So we're not interested in heat waves per se, right? Or drought by itself. It's what those consequences of that heat wave or that drought might be for society or for ecosystems that society cares about. And so risk is therefore a product of the interaction of changes in climate events, which are called hazards here, and characteristics of society, things that make society or ecosystems exposed to those climate events, like having how many people are living in the way of sea level rise or where lots of heat waves occur, and vulnerability. Not only do people experience those climate events, but they're actually vulnerable to them. So, you know, a household that is living in a tin shack in a low-lying coastal area is not only exposed to flood risk, it's vulnerable to it. Whereas if it's a modern sort of flood-proof building, it's much less vulnerable to, even though it's exposed to the same risk. So all of those things matter. So if you're judging risk, you need to take into account not just climate change, but also conditions of society, and not just today, but in the future when they are exposed to these climate hazards as well. So key risks are some subset of all possible risks from the interaction of climate and society, which we care especially about because we think they might be something that's dangerous enough that we want to avoid, right? So that's why there's a little circle with key in the middle of the risk area. So that's risk, that's key risk. So we went beyond that to say, okay, we're going to be collecting ourselves from the scientific literature what potential key risks might be. We're going to be asking other authors in all the other chapters in the report that are looking at different aspects of climate impacts to report to us what they think are key risks, and we need to give them some guidance. And so here was the guidance. Here are aspects of risk that could make them important, sort of more important than an average run-of-the-mill daily risk. One is if the risk has a particularly large magnitude or probability, something that is very likely to happen and would be large is a bigger risk than something that's very unlikely and small. Also, is the system that it would affect important? That matters too, right? So if it's a risk to human life, that's a big deal. And it's a bigger deal than if it's a risk, for example, to, let's say, health but not a mortality risk, right? Still important, but maybe a bit less so than all-out mortality, and so on. Third, the timing, some aspects of time here. things that may happen quickly in the future are likely a bigger risk than something that we would have lots more time to prepare for. And those risks that are irreversible, that once they happen we can't do anything about, are a bigger deal than those that we could reverse. So species extinction, classic example, right? Really tough to do, maybe not impossible in the end, but certainly right now impossible to reverse and should be taken into account. Things where the vulnerability or exposure of people or ecosystems is really hard to do anything about plays into whether a risk is larger or not as well. So if you have, say building infrastructure, high value buildings that are in coastal areas that have a 50, 60, 70-year lifetime, it's going to be really tough to just pick those up and move them out of the way, right? So that's going to be something with persistent vulnerability or exposure. And finally, a limited potential, and this was especially important in some of the very high risk, is if you can't really do anything about it once it happens, very little potential to adapt or to reduce risks, then that's an especially important risk compared to one that also may be important, but that you have many more options for coping with. So those were the criteria in putting, in collecting key risks. And this was a big job, as you can imagine, because there's lots of different sectors, as we've mentioned, water, forests, fisheries, agriculture, health, and so on, in regions around the world. And so there's lots of potential key risks. And even though we've made a little bit of progress on saying, okay, we're going to manage this difficult to manage project of sorting out what the consequences of climate change are by focusing on not just any risk, but the key risks, we're still going to end up with a lot of them, right? And so that's where the reasons for concern come in. And as I've said, the idea there is to aggregate some of these key risks and impacts and vulnerabilities into a smaller number of categories that are easier to communicate, at least the big picture, assign risk levels to these categories as a function of global mean temperature, right? That's what goes into the burning embers diagram. And that this would be helpful. It may not be the only way, right? It's just one way of trying to make sense of the impacts world, but one way to help interpret the scientific literature in the context of the objective of the Framework Convention. Okay. Right, and I did mention before exactly what the categories of risks are. But just as a quick reminder, unique and threatened systems, extreme weather, either globally aggregated or distributed impacts, things that are important globally or to some subgroup of the population, and large-scale singular events. Okay, so what have these looked like historically? Well, when this first came out in the 2001 IPCC report, this was the burning embers diagram. Same 5 categories. Those have not changed. And you see some embers are yellow already at the black line, which is current climate. They get red at different rates. The ones on the left get red at lower levels of climate change than the ones on the right. When this was reassessed, new scientific literature update these risk judgments. In the next IPCC assessment in 2007, this is what it looked like. So you see the red colors are creeping down. That's the idea here. Don't worry about the writing on it. And so the judgment of authors at that time was that based on the evolution of the science of climate impacts, is that risks were larger than we understood 6 or 7 years ago. The most recent set, and this is the one I worked on, for some reason we changed the color scheme a little bit, that continued for the most part. There was actually 1 or 2 spots where the reverse happened. Risks were judged to be a bit less than they were last time, but generally the red crept down a little farther, and possibly our biggest color innovation was that we introduced purple. And so that was introduced actually for a specific reason. I remember actually when the report came out that an economist who works on impacts tweeted this figure and said, big innovation, they've introduced purple. Next time it will be skull and crossbones. And so maybe in the sixth assessment report we'll do that. But that was done because if you look at the fourth assessment report, there's a big expanse of these embers that are just red. And it doesn't differentiate in there. The difference in risks between 2 or 3 or 4 degrees is just high everywhere. But we actually have lots of information on how risks may get worse. The key distinction in the definition of high versus purple, which is very high, is the limited ability to adapt. That it's not only a high risk, but there's really not too much you can do about it. And we'll come back to a couple of areas of purple and what they mean in just a minute. You know, for the current version of the reasons for concern, I think they're different from the recent ones just in that we have put in more effort in being clearer about the concepts involved, that this is a risk-based framing, and we have been explicit about criteria for making judgments about what's a key risk and what's not, which really wasn't as much the case, and therefore had a more consistent approach to judging risk, which hopefully is something that's more reproducible from, if you ask different groups of experts, that they have a better chance of actually coming up with similar judgments about the same material. And of course, the judgments have been updated. And so as an example of that, you know, so we have these criteria for what key risks are. If we want to then transfer those to risk judgments for a reason for concern, a whole category of impacts, what's yellow, right? What's red? We need definitions of those in order to make those judgments. So here's what they are. The definitions were that white, as I mentioned, is undetectable, which means that in order to be yellow, in order to get into to go from undetectable to moderate, there have to be studies that have detected that something has actually happened. There is an impact. If we're talking about heat wave impacts on mortality, we have to have studies that say there was a change in the incidence of heat wave mortality. We've detected it. And we can attribute it to climate change, to human-driven climate change, right? And that's a statistical problem, that it can be difficult to both detect and to then attribute why did we get an especially bad heat wave with a lot of deaths, say the Paris heat wave in the 2000s. We may be able to easily see that's an unusually high number of deaths from a heat wave, but it's a difficult matter to then say, well, is that because of climate change? Statistical problem. So you need to be able to do both, and it has to be about the impact on society or ecosystems, not that we see the heat wave happening and we think that heat wave is due at least in part to climate change. We have to be detecting and attributing the impact consequence. Then it becomes a moderate impact. As you get up toward red, there may be an increasing, the idea is that this should have an increasing magnitude or likelihood of the impact occurring, and that red as a high category of impact means severe and widespread impacts. And so if we think of it in terms of these 5 criteria for key risks on magnitude, likelihood, timing, irreversibility, and so on, it has to be high on at least one of those and maybe several. Now, severe and widespread, so maybe that helps, but then you can say, well, what is severe and what is widespread? And that, I think we have some more work to do on actually defining that more specifically. And purple, as I mentioned, high on all the key risk criteria, and especially having limited ability to adapt. So these are the distinctions. Okay, so this is the updated version as of the actually after subsequent to this most recent IPCC report, the fifth assessment report, this group of authors that was on the first slide got together and wrote a paper on this to try to improve the clarity and transparency of the reasons for concern and the burning embers diagram as it appeared in the last IPCC report. It seemed to us and to many people who looked at it in the IPCC report that this approach meant to clarify and make it easier to understand impacts was not entirely clear or easy to understand. So this paper was an attempt to do that. Now, one of the ways we tried to do it, which I think from a graphic artist point of view might be the opposite of the advice you would typically get, is we put more stuff on the figure. And so what we put on there, as you'll see, the colors are exactly the same as the previous versions that I've showed you. But there are these icons, and the icons stand for particular types of impacts. And what they're meant to illustrate is these are the particular types of impacts that were really especially important in making that risk judgment. So on the left there at the bottom, why does the unique and threatened system risk go from white to yellow down there toward the bottom? Well, there's three icons that are going to be a bit hard to see here, but one is a coral reef, one is an igloo, that's our Arctic system, and one is a mountain, so it's mountain systems. And that represents detection and attribution studies of those three systems that went into that judgment, and so on. So each of these icons is meant to illustrate what really made a big difference. There are also these colored dots underneath, and these represent whole categories of key risks which contributed in a general sense to the risk judgments for that reason for concern. But it was difficult to tie a specific level of risk to a specific level of warming. And this is actually the main challenge with the impact scientific literature. There is an enormous literature on climate change impacts, of all kinds of impacts taken from all kinds of perspectives. There is a vastly smaller literature in which you can read a paper and say, aha, okay, for this impact, coastal damage is exacerbated by sea level rise. Here is a damage result that occurs at 2 degrees, and here's another one that occurs at 3 degrees. And this one is 50% higher than that one, and that we can use to inform a judgment like this of how this risk varies with global mean temperature. It's a surprisingly small number of studies, a surprisingly small fraction of the impacts literature. I'm going to make something up that may offend somebody who works in a particular area, but lots of studies, perfectly useful might be, well, we think governance, the effectiveness of governance is important to impacts, so let's look at how governance enhances or restricts a city from being able to adapt to environmental stress. Great study, many studies like that in the impacts literature. Very difficult to do anything with that when you're trying to make judgments like this. So those circles at the bottom, which we won't talk about too much anymore, represent that for this particular reason for concern, there's lots of studies of that nature that support the general idea that risks get worse as climate change, we get more of it. But we couldn't really go farther than that in making the kind of judgments. Okay, so let's look at the details, and I started to say a little bit about unique and threatened systems. So let's just walk through that one. Where did these colors come from on this ember? So first, the definition of unique and threatened systems is that it's a system, could be an ecosystem, could be a human system, could be a combination of the two, in which there is a limited geographic range for it, and it's a climate-determined range. It may have high endemism, meaning the species in that area occur just in that area, not in other areas, or something else that makes them distinctive. And so you see a list of some examples of what would qualify as a unique or threatened system. Coral reefs, unique indigenous communities may only exist in one place, tropical glacier systems, mangrove ecosystems, the Arctic, for example, meaning both the climate system of the Arctic and the human systems that it interacts with. So that's what it is. So these dots, there's these colored dots down there, and these represent categories of key risks, as I mentioned. And so the areas that sort of inform the overall impression from the literature that things get worse with more climate change are risks to coastal zones and small island states, marine and coastal ecosystems, terrestrial and inland water ecosystems. Lots of studies in that area that indirectly inform these judgments, but not directly. So how about the direct ones? So the recent ones, the fact that this reason for concern, the judgment is that we are already at moderate risk, is because there have been detection and attribution studies that have determined or identified a climate effect on impacts on Arctic ecosystems, on mountain systems, and on coral reef systems. So all of those things are occurring, and we can say they're occurring at least in part because of climate change, not just a random chance or natural cycles. And those studies, by the way, were also assessed in a separate part of the IPCC report, these detection and attribution studies. So we were looking at those. I think I have it on here. Yes, just to give you a little bit of a sense of, are there lots or little, or how does one assess that? And this was done in a little bit more detail than that. If you remember from the definition of moderate risk, you had to have detection and attribution with at least medium confidence of impacts in a particular system in order to qualify for meeting the moderate risk test. This is a summary of studies broken down by the confidence in their conclusions in detecting an impact. That's on the bottom here. So you go from very low confidence here to high confidence here, and the confidence in detection. And on the vertical is confidence in attribution, right? This is something happening? Is it because of climate change? And you have to have at least medium confidence in both of those things in order to qualify to be a moderate risk. And so if you're anywhere in that red box, then you qualify. And those colored circles represent types of impacts that are in the scientific literature. The red ones are human systems, yellow is physical, blue is marine, and green is terrestrial. And the size is the relative importance of climate to those impacts, right? There's an attributable effect, but it may be a small one or a large one. So we get here that in these assessments, there's been a major role of climate change in studies that have looked at Arctic marine ecosystems, Arctic shrubs, the livelihoods of people living in the Arctic, so it's a human impact, and then as well coral bleaching and therefore effects on that ecosystem and in mountain systems. So that gives a sense of that's tracing back to the underlying scientific literature. These are the studies that went into saying, okay, this means it's now a moderate risk. We've detected it, attributed it, and it seems important enough that it's moderate. That's the test that has to be passed. Now, I'm going to skip then to the transition between red and purple. So where did this decision to say risk goes from high to very high, around 2.5 degrees come from? And these are from a couple different types of studies, some climate modeling studies on projecting changes to the Arctic ecosystem that are very substantial, and that is having an ice-free Arctic in September. And most models climate models anticipate no ice in the summer in the Arctic by about 2.5 degrees of global warming. In addition, there are a number separately of studies of not species extinction, but vulnerability of species to extinction at around that level of temperature change, and even a bit lower, in which pretty substantial numbers of species or fractions of categories of species are at risk of extinction. They're not predicting extinction. Right? In the ecosystem literature, this is typically kind of the best you can do is project a certain level of vulnerability to extinction. But that was judged as pretty substantial, and that those outcomes would be difficult or impossible to reverse, and little that you could do to adapt to it. And therefore, so in particular, the difficulty of adapting qualified to say at about that level of climate change, this should be a very high risk, not just a high risk. Now, at the same time, to give you a sense of some of the uncertainties involved, why in the middle there does yellow turn to red at that particular 1.5 degrees of warming? Because it was halfway between the other two. And in the generally the lack of any other specific studies that had detailed results at those levels of climate change, we just put it in the middle and said, well, it's in between there somewhere, so we'll put it in the middle, and we smear out, there's a gradation of color meant this is uncertain where we go from yellow to red, and so we don't know, but it's in there somewhere. And that's an important thing to have in mind, right? There's no icons there. And there's no icons there because there's no specific sector or system that informs that judgment. And often these burning embers get used without these qualifications, right? People just look and say, oh, that's red at 2 degrees. That's a big problem. Like, well, we didn't actually know where to make it red. All we can say is it's somewhere between, that blue line and the purple. It could be anywhere in there. Okay, so let me go through one more, and I think I'm going to do just RFC 3, the distribution of impacts. Right, and this is, as I mentioned, impacts that disproportionately fall on some group, either some geographic area or, say, low-income populations or so on. And where did these judgments come from? And an important point that I want to make here that I know these are probably hard to see, but 3 out of 4 of the icons on this one are tractors. And so you might think, well, there's many different impacts that could be distributed unevenly, not just agriculture. And yet, the key judgments for these transitions are made primarily on agriculture. So one of the take-home messages already is that there is insufficient literature on other impacts on the energy system, on conflict, on migration, on things that may be unevenly distributed around the world, that we don't have good studies for that can clearly tie outcomes to specific levels of warming. And so some other things to keep in mind. So the transition from white to yellow happens around current levels of climate change, and that is because there are some detection and attribution studies that we've seen yield changes in some crops in a couple regions that have been attributed to climate change, to climate differences due to human forcing of climate. However, that's not an impact on people. That's an impact on a plant. So what we're really concerned with is, did that affect food prices? Did it affect land use? And we had to grow more food or less food or shift it around, and that land use affected people or ecosystems? Did it affect hunger somewhere? We have no detection and attribution of that. This was sort of squeaked through the definition, which is we're really not supposed to squeak through, by saying, well, we're going to interpret that as an early warning of a human impact. But there has been no detection of a human impact, actually. And although there are studies that have detected negative impacts on crop yields, there are also those that have detected positive impacts on crop yields. attributed to climate change. So both exist. That doesn't mean you don't have to worry about the negative ones, but it's important context to have in mind, which I think is typically lost in just looking at the Bernie numbers diagram by itself. Okay, in the middle, things get worse. Water limitations come into play, but I think what I want to focus on more is the high end. This does start to turn purple here, and that indicates, as we said, some evidence that there's a limit to adaptation. And so at high levels of climate change above 4 degrees, it gets tough for agriculture to cope with the effects of climate. However, there is a caveat to that as well. That conclusion, which appeared in the IPCC and the agriculture chapter, was based on a particular type of adaptation. It was, they use the word agronomic adaptation. You can think of it as farm level. So farmers, if they switch crops or move the planting dates or change the amount of irrigation or fertilizer at some point or around 4 and 5 degrees, it really didn't help. It stopped helping, and you couldn't reduce your impacts anymore. But what was left out is there are other things that food systems do. For example, international trade. So if it gets harder to grow food in one place, you can import more, right? Now it depends. You have to have a distribution system. You have to have functioning markets. You have to have a good trade system, but it's feasible. You can change the amount of land that you're planting, right? If your yields are going down 20 or 30%, one way you can maintain production is plant 20 or 30% more land in crops and maintain the same level of production. That may not be an attractive option to do depending on your land availability, but it may be possible. Those were not considered in this limits to adaptation judgment here. So it's important enough to sort of signal there may be some issues with adaptation, but it is not really an all or nothing proposition here. Okay, so we got under the hood on a couple of these, and if we sort of stare at this figure long enough, which is fun, I recommend it. You can get the paper online, and you can make a poster out of this. You can put it on your wall. It's got, I like the frog icon. That's our biodiversity icon. But if you look at it, then hopefully part of the communication aspect of the icons and some of the other aspects of the figure help with communicating as well some of the challenges and limitations to the reasons for concern and the Bernie number diagram. So one is that the evidence base is really uneven, right? So you don't really get that from just looking at the Bernie numbers at all. The amount of evidence varies across these different categories. Even though the aim is to categorize risks to people and ecosystems, we still have in there a lot of judgments that are based on impacts to the physical climate system. And that's just, most of the literatures, well, I don't even know if it's most, but a lot of the literature that can be tied to global average warming is on physical climate consequences, and we're still catching up on impacts to people and ecosystems. Some of these reasons for concern involve lots of different sectors or regions, but we're drawing on evidence only from a few of them. So the agriculture example that we just looked at. Some of these risks, I won't say are absolutely double counted, but I'd say they're overrepresented. If you stare at that, you'll notice there's a coral reef icon on reasons for concern 1, 2, 4, and 5. So is our overall picture of risk, how much red is on all of this diagram, overly emphasizing one particular system? Maybe. And that's true for a couple of others as well that show up a lot. And so they just have to be used carefully. The way I think of it is I cringe when I see people take that diagram, draw a line across it, and say 3 degrees means red, red, yellow, purple. That's our risk. And 2 degrees doesn't have a purple, and it's got 1 red and the rest yellow, so then we're better off. I think of it as if the Bernie numbers diagram is a starting point for your evaluation of risks and say, I wonder why that is. let's go look at what judgments are informing this. Great. If it's the last thing you do in evaluating risk, that's a problem. And unfortunately, it does get used that way. Okay, so I'm just going to skip to the summary list of future directions. Where do we think we want to go with this next time around in assessing risk, and what needs to be done to improve this enterprise? One is that we need the underlying research base. So you can hopefully get that sense. We need more studies that can more clearly tie risks to levels of future climate change. Many of them don't account for changing societal conditions, many of these studies. So we need to do better at taking exposure and vulnerability into account, not just projecting the future of the climate system. And as I mentioned, we've defined to some degree what these levels of risk mean, but there's still a ways to go. To me, particularly the severe and widespread just sticks out every time I hear somebody say that. Oh, yeah, you guys define it severe and widespread. I'm like, yeah, but what is severe and what is widespread? Some risks, for example, ocean acidification, are not well predicted by global average temperature. They're better predicted by some other aspect of the climate system. And so even doing this as a function of global mean temperature is not always a great idea. And maybe there's a way to better, I mean, we have these 5 very aggregated categories that maybe breaking it down a bit more and being less aggregated would be a good idea. But I will stop there and happy to take questions and any suggestions or ideas that any of you might have on how we can do this better the next time around. Thanks.
So the disaggregating, that might be relevant to the coral reef appearing as a risk in multiple categories. Are those sort of correlated?
Yes. So, yeah, I mean, there's a couple ways to think about it. So if you replaced these categories with some other set that was more disaggregated, and one of those categories was coral reef systems, just because we know a lot about it, it's a big system, it deserves its own, that might help, unless you then follow that through to its logical conclusion and end up with 30 different categories, right? You'd have to guard against that. Another way that, it's an issue, and I'm not too sure what to do about it, but, one of the reasons we discussed this idea, in the globally aggregated reason for concern, there's 2 things that dominate that. One is economic consequence, just the dollar value. What does it cost globally to the impacts of 1 degree, 2 degrees, 3 degrees? And the other is impacts on biodiversity that are globally aggregated, percentages of species and so on. And those are really not very commensurate, and we have very different levels of evidence. We have few, if any, studies of global aggregated monetary costs at high levels of climate change. So at 3 or 4 or 5 degrees, there are no studies. So you get this burning ember that has judgments based on a mix of categories for lower levels of warming. And then at higher levels, there's some biodiversity studies, but no economics anymore. And so you've got like a compositional problem. You've got potentially a bias in risks because the underlying composition of topics that you're even assessing changes as you go from lower levels of climate to higher levels of climate. So there we thought about, well, look, just for this one, maybe we should just divide it up and say globally aggregated economic impacts and globally aggregated, say, biological or ecological impacts. That's a thought going forward.
We have a question from online here. Can you explain a little bit more about the methods that you and others use to come up with these assessments?
Well, and so maybe the, I don't know if the question is more about what are the methods for the impact studies underlying it, or once you've got a bunch of impact studies, how do you come up with an assessment like this, like a set of reasons for concern? Where do you put the red, where do you put the yellow, and so on? You know, what I can say is, so I mean, hopefully I gave a sense of, you know, this is generally, there's no formula for it. There's not a quantitative program where you put a bunch of stuff in and you get the answer out. It is an expert-based judgment where a group of authors puts together the literature, discusses it, tries to inform the judgments with quantitative outcomes wherever possible, and then makes a judgment that is consensus in the sense that everyone can live with the answer. What I would like to move toward is something that is, I mean, it will never be entirely quantitative and automated, but if we can make the definitions more specific, and if there are more studies with quantitative results, then we can do something more quantitative. So I'll give you an example, is that there are a number of studies where a particular outcome for the agricultural system is numbers of people at risk of hunger. That's what you're interested in the end. And so that is something where you might say, okay, if we have enough studies, we could say, well, if the numbers at risk of hunger go up 20%, that's a high risk. If they go up 50%, that's a very high risk. And then you could put together, right, this is a set of quantitative results with a single metric of the outcome, numbers at risk of hunger, put it in a database where you might have, you know, instead of 6 studies, which is probably what we had this time around, you might have 50. And then you can get a better sense and a more reproducible methodology of saying, here is exactly why we had this many studies out of 50 that said it's going to go up more than 50%, therefore we made it very high. I would like to move toward that as much as we can. And that requires people making the judgments to agree that that's a good way to do it, which is the first obstacle. And the second is, do we have the 50 studies underlying it? And currently, by the way, my guess is we don't have 50, but we have a lot more than 6 now. We probably have more than 20. And so I think we're getting into the space where the literature is starting to get to the point where we can do something more, maybe systematic is the word, for doing this.
So you kind of, I think, alluded to this earlier, the previous question, but I was wondering if you had any sense of a direction towards maybe something of the concept of ecosystem services and kind of converting these risks into dollar values, such as maybe water quality and how we would pay to improve water quality, but then assess these risks in terms of a dollar amount that we would have to pay for in terms to get water quality to that value. Is there any sort of more direction towards consolidating in terms of maybe just a single dollar value through that and kind of quantitatively assessing ecological risk and biodiversity risk in terms of like replacement cost if we were to remediate them to back to a climate scenario or reversion to that? Right.
No, and so if I think I got the gist of your question, which is a good question, and it's one about metrics for measuring outcomes, although, you know, it's a deeper question, right, about valuation. And this was a point of discussion. It is also one of the reasons why I think that in any effort to simplify, which to me is inevitably going to require some level of aggregation or sort of considering multiple impacts in a single category, we're never going to get to the point of being able to put everything under one metric like dollar values and then make a judgment, say, for globally aggregated risks where we, right, kind of, you know, one version of what you're saying, one way things are done might be, well, hey, your globally aggregated risk has economic values and ecological impacts. Convert the ecological impacts to dollars. They're both in the same unit. Add them together. You have no aggregation problem anymore. And that is a possibility. The problem is as you're pointing out, is that there are different ways and different measures to value ecosystem services. There's one way to do it. It may include existence value. And that metric may not be dollars. And so I think in the end, that there are studies out there like that evaluate consequences and try to value them with different metrics than, say, impact on gross domestic product. And in the end, the way they're handled in this framework is you put them on the table and you say, well, at 2 degrees, what happens to the risks that are included in the globally aggregated reason for concern? You say, well, I got these dollar values that are based on GDP. I've got these ecosystem service values, which are a different unit. I've got percentage of species lost. And we're going to discuss, and we're going to make a judgment about how do we want to handle that. And do we say this is a high risk if it seems high for 1 out of 3, 2 out of 3? Do we need all 3? And so I think at the moment, the best you can do is be as clear as possible in what you did and report that, and then try to communicate it. And this was what was done here, and I'm sort of trying to point out, well, here's a method of simplifying and communicating a multi-objective, complicated impacts literature that necessarily simplifies things and aggregates them. And that's got some good aspects to it. You got 5 things to look at, not 100. But it's got some bad ones, like the list of challenges that I put up there, and I would add that as one of them. So, there may be ways to make more progress on something that does have wider agreement on some ecosystem service-based evaluation that helps. Otherwise, I would consider it an additional approach that has to be put in the mix of outcomes with different metrics that have to be merged together in a synthetic risk judgment that's subjective in the end. You just got to be clear about how you made the judgment.
I was surprised that human health was not more broadly represented across the impact categories. What are some of the main challenges to including health outcomes in the DNA analysis?
Yeah, that's a good point. They are reflected, right, and they could be reflected in several different areas. The way that they appear most visibly in the assessment is in the extreme events reason for concern. And I think that reflects the nature of the underlying literature that in the health area, this has been one of the starting points for looking at potential health consequences, has been on either tropical cyclone-related natural disaster-style risks or heat mortality, also cold mortality. So I think it is reflected there. I think one of the challenges does reflect a couple of the other challenges. One is in having a literature that not only addresses these health issues, but does it at a scale, say a national level study or continental or global, that can be easily tied to global average temperature outcomes, right? There are a lot of health studies that fall in sort of the governance example that I gave that may look at a particular issue with the health system and its relation to climate. Very valuable study, very valuable for responding to the climate issue in a particular way, but not so valuable in this sort of aggregate big picture way. The other is that to give an example from extreme events, that is another place where the number of studies of physical climate system outcomes of extreme events vastly outweighs the number that have looked at health consequences of those same events. So in the judgment of going from undetected to moderate, there were a couple of studies that have detected and attributed mortality impacts already, but most of those are on the existence and of the heat waves themselves and not of the mortality impacts. for the judgments of going to higher levels of risk from extreme events, they are not informed primarily by projections of, say, heat mortality at higher levels of warming, because there aren't that many studies that do it. It's primarily based on projections of the frequency of these extreme events themselves. And we state that here and say, okay, we set up these rules, now we're breaking them because we don't have enough studies of human impacts to make a judgment, so we're going to make this judgment based on robust predictions of increases in frequency, magnitude, duration of, for example, heat events in the near-term future, and we will call that an increasing risk, even though we don't have a study that translates that into mortality impacts. So they appear, and maybe it's something that will appear more widely across other reasons for concern in the next version of this.